It's part two now. The first brown type was constructed in Buffalo, New York, at Ohio Street, crossing the Buffalo River. Now, this is the first brown type, Ohio Street brown type basketball bridge across the Buffalo River in Buffalo, New York. It's the first bridge built, replaced with a vertical lift bridge. So this is the first brown type basketball bridge. A cam girder is attached to the trusses that substitute for the articulated I bar linkages. The counterweight ropes are wrapped around the face of the girder and anchored to the main trusses at the first lower chord panel point from the trunnion. The face of the girder carries the grooves for the ropes. It's curved so that as the leaf is open, the ropes are unwrapped from the cam girders. Their effective lever arms are reduced and balance of the moving leaf is obtained in all positions. The counterweight moving vertically. See Movable Bridge, Superstructure, Volume 1, O.E. Hovey. So, and now, app. Here go AF app, painted an unusual trunnion type basketball bridge that the counterweights move in its opposite direction. App worked with the American Bridge Company and constructed a few of the types. The first type was constructed in Detroit, Michigan, used by the Norfolk Southern Wabash Railroad Company across the Rouge River. This is the first app type basketball bridge built. Yep, so, and it's still in use today. It was built in 1923. It's it's a 62 feet long double track structure between the centers of bearings, and the counterweight is 73.5 feet long from the upper chord. And from the upper chord panel point, two of the main trusses tensions member extends diagonally upward and rearward. A rocker link connects to the heel of the truss at one. The counterweight is a steel box with arms which are hinged to the top of the tower. A compressor link pin connected to the counterweight box is articulated to the tensions of the operating link, which is hinged to the rocker link joint. A track in the tower is inclined with a horizontal plane. This joint is pinned, connected to the truck, adapted to roll down the inclined track with rack. The trucks at the two sides of the bridge are connected by box girders, which carries the machinery and the operator's house. Power is applied by the pinions engaging the racks on the inclined track girders. As the counterweight and operating link joints rotate in the arcs of the circles and power is applied along the buses of the scissor joint angle and almost extinct balance that attain in all positions of the moving leaf. The scissors joint link trucks, and the ends of the counterweight are in the plane of a moving leaf truss and move within the tower, which most be wide enough to allow clearance. The operating machinery is driven by two 100 horsepower electric motors through an equalizer and reduced gearing located on the machinery girder. When the span is open, the trunnion carries the maximum of loads, the the counterweight, and the connections, and the counterweight box swings inside the triangular tower and hangs like a pergola. When the closed position, the trunnions are only lightly loaded by the counterweight, and its connection swings up to the truck on the inclined track. See app on page 134 on Movable Bridge, Superstructure, Volume 1 by O.E. Hovey. There are two other app training basketball bridges in the state of Michigan, 3 in California, 1 in Texas, and 1 in Wisconsin. A total of 8 app basketball bridges in the United States. They are only carry railroad traffic. Yep, they only. Yep. App has some success developing these bridges. Are still in operation now. You got 5 app basketball bridges now because you got the Port Huron was removed in 2023. So, and now let's go to page. Page. This Page trunnion type basketball bridge was painted by John W. Page and designed by William E. Hughes. Page had worked with Strauss on basketball bridges. There are only a few Page type, a double trunnion type, formerly in San Francisco, California, 1 in Hammond, Indiana, no longer operates and is removed, and 1 in Chicago, Illinois. This is the only one still in service for the Page and Etta Railroad. Now this is the first Page trunnion type basketball bridge in Chicago, Illinois. This basketball span contains the counterweight and approach span, which pivots with the basketball span when raised for river traffic. The approach span is riveted on a steel plate girder, while the basketball span rests on the concrete abutments. The bridge tender's cabin is located on the north approach of the cabin and is on a story brick building with a hip roof and chimney and everything, right? So, Bellador basketball bridges. Bernard F. Bellador, 1729, is a drawspan with a sliding curved track that rolls down with the counterweight when the basketball span is raised. The basketball span is hinged at the balance beam with cables attached between the upper beam to the end of the drawspan. The pinions rest on top of the balance beam on the approach pier. At each side of the span is a chain which leads from end floor beams on the pinion upward. over the sheaves near the rolling counterweight and track to the rolling counterweight as the bridge rotates above the hinge. Counterweight rolls down the track with rails. The track is curved in order to attain the balance of the rotating leaf with the counter weight of the fixed value at all angles of the bridge opening. The example of few building door basket drawings is the Glimmer Glass Bridge in Brooksville, New Jersey, crossing the Glimmer Glass Channel. See, this is the Glimmer Glass Basket Bridge across the Muscatine River, Intercoastal Waterway, Glimmer Glass Channel at Burial, New Jersey. See, a railroad drawbridge also in New Jersey, crossing the Berries Creek, a double leaf Ohio Street Bridge formerly in Buffalo, New York, and one in Coney Island, New York, which are the few belly door bascule bridges in the United States, but commonly in Australia. See Hispel Bridges Conference on belly door bascule bridges. Now let's go to this one. Dutch style bascule bridges. The Dutch style type is a balanced beam heel trunnion type, painted and designed by an Anno inventor, but they are more commonly in Europe, Holland, and the Netherlands, etc. There are few Dutch type bridges in the United States, a couple of them upstate New York, and one in Minnesota that has a double section for pedestrian walkway. See, this is an example of it. The Minnesota Slip pedestrian drawbridge across the Duluth Canal, Duluth Superior Harbor, located in Duluth, Minnesota. So this is an example. The Dutch type heel trunnion bascule bridge, a single leaf trunnion bascule bridge provides balancing of the span through connections of the tensile link and the balance being framed to the leaf at the forward of the main trunnions. Some links are far placed enough forward to the bascule spin like a simple spin of the dead load. Some bascule links are connected to the bascule leaf at the midpoint on the spin of the thereabouts of the bascule spin, like a two-spin continuous bridge for live load with both spins cantilevered of the dead load. The center link heel trunnion bascule bridges are cantilevered that causes the counterweight bottom structure and the operating machinery. The end of the link to the bascule spin allows the leaf to act as a simple span that eliminates the live load stresses in the operating machinery. See Movable Bridge Engineering, Cognitive page 138, 139, and 217. So, now, Hawkins frame. Okay, so let's go there. The Hawkins frame drive trunnion type bascule bridges designed by Leonard O. Hawkins are mostly in the state of Florida. They have the usual drive systems of the trunnions on the Hawkins frame. The Hawkins frame is a connection between the bascule leaf and to the pier on which the mounted the drive motor brakes and reductions to gearing. The frame is connected to the bascule leaf in such a way that the rocker pinions are mounted on the hocker's frame and constantly mesh with the rack side middles that are fixed to the special rack girders on the leaf. Inboard of the two main girders, the frame flexes when the open position and close causes the changing of the shape of the bascule leaf in the open position as opposed to the closed position. Some Hawkins frames have single rack and pinion on the bascule leaf. Most bridges have two pinions that drive two racks. The single rack is on the low longitudinal center line a few feet from the Hawkins frame drive train bascule bridge. Works against the two racks and pinions that are usually parallel shaft. A different reducer mounts on and usually additional exposed of the open reduction gearing between the differential reducer output shafts and the rack pinions. And see, this is the Hawkins frame. State Route 44 bascule bridge across the St. Johns River between Astor and DeLand, Florida. It's a Hawkins frame trunnion type. So this is a Hawkins frame. Now this is an example right there. Waddell inheriting trunnion bascule bridges. The Waddell inheriting trunnion bascule bridge has a number of distinctive features. The trunnions, which are aligned with the top chores of the trusses, they're made of special steel casting with the rigid attached to the box girder, spanning the distance between the trusses. The free end of each trunnion has cylindrical bearing with its axis parallel to the plane which the other truss. This bearing fits to the cup mounted on a standard or tower anchored in a pier. The objective of this cylindrical bearing is to permit a slight rotation due to the deflection of the box girder connecting the trunnions between the cylindrical bearing and the end of the box girder is an enlargement of the trunnion or symmetrical ring having a spherical surface. A hub casting board to fit this spherical surface turns on the symmetrical ring and supports the truss. This gives the bearing of the large area of the permits of the using the lower unit pressure. This spherical surface also provide for the slight bending of the trunnions in a plane perpendicular to the truss as the deflection of the box girder varies with the change in the loads, thereby preventing the binding or any other unequal destruction of loading on the two sides of the truss that will avoid high secondary stresses. The span of that is operated by a system of cables cemented by equalizer bars to each truss at the ends of the segment of the short arm of the basket. These cables follow the curve of the symmetrical end, pass around nearby idler sheave under the floor, and then to the other attachment of the sack metal. Provision is made for reversing the rotation, winding drum as the spin is balanced above the center of rotation of the concrete counterweight and the upper end of the symmetrical extension from truss to truss. Only significant power to overcome the frictions of the interior of the moving parts is needed to operate the span. An example showed of a Waddell inherited train type bridge crossing the False Creek in Vancouver, British Columbia, Canada. See, this is the Waddell inherited type of basket bridge, you see? Yep, across the False Creek at Vancouver, British Columbia, Canada. It's a Waddell inherited type. So, rolling bearing trunnion basket bridges. The roller bearing trunnion type basket bridges are painted by different inventors, some such as Montgomery Waddell and John P. Corin roller bearing trunnion baskets. The first roller bearing basket bridge was developed by Montgomery Waddell. There are two distinct designs for this type of basket, and one circular end of each truss of the moving span rests on the nest of solid rollers that are effectively connected to each other by spacers, and which are supported by cylindrical cup shaped band. These rollers have trunnions which rest on the curved track and which have diameter of one half of the rollers. Consequently, the translation of the rollers is on the fourth rapid of the cylindrical surface which bears them. In the other design, the surface rests on two stationary compound rollers per truss of the type of rolling bearing basket. In both types, there are more, especially in the second frictional resistance. Motion is reduced to a very small quantity of compound roller consists of single large solid cylinder surrounded by a nest of small solid rollers that are